Sometimes when coding, we realize that TypeScript cannot really infer things properly. So today we're going to have a look at a powerful weapon that we have to give TypeScript a gentle push in the right direction. Hey there, I'm Attila, and every now and then I wander into a dark alley with TypeScript. My control flow is going great, things are working in the browser, but somewhere later I realized that type inference is messing up my autocompletes. You probably may recall a situation when something similar has happened to you. The language service provider in our code editor can't really say if that bird is a duck or a goose. And our types are widened beyond logical explanation. And I do mean logical explanation because we've seen sometimes that TypeScript avoids to narrow some types down for the sake of safety. In our array filter problem, for example. If you don't remember, you can check it out. I linked it somewhere. So the shortcut is to slap an assertion into and get on with your life. Like, you know better, TypeScript will take it and that's it. But that's not a good solution because it's robbing you from actually preventing that bird from being a goose during the runtime. And what I'm trying to say is that if TypeScript compiler decided not to narrow that type, there is reasonable doubt that this thing might not be what you're expecting at runtime. And by creating that assertion, you're robbing yourself the chance of catching this. And that's a bug bomb waiting to happen. So a proper step to fix this is by using a type predicate. But what is a type predicate? According to our favorite robot, a type predicate is a function that returns a Boolean value and is used to determine whether a value conforms to a specific type. So at runtime, a type predicate is a Boolean check. But when editing code, the type predicate behaves as an assertion. It's the perfect guarding rails for us to assert without the risk of things blowing up unexpectedly. So let's check it out how it works. So let's say we have these two types. I have the motorcycle that's supposed to have 2 wheels, and I have a car that's supposed to have 4 wheels. And then I have the vehicle that can be either a motorcycle or a car. I'm going to have this function that's like could be any kind of type function that's returning a vehicle to me, and it's gonna return 2 wheels. It's hard-coded that I'll have 2 wheels, so technically if I have this, it should get me something. But no, like the bike, that bike's still a vehicle, and that's because like in this very contrived example, it's quite obvious that it should be something else. But like if you're going from an API or stuff, like sometimes we cannot narrow this down. Like now I'm using a type annotation, but imagine that this is an SDK and things are like deep down in your library land. So fixing the annotation is not an option in this case. So your gut reaction would be to have an assertion here like, yeah, it's a motorcycle. And then yes, our types get fixed. But what happens here is that eventually I can switch the logic here for something like this. And no, now my types are saying that this is still a motorcycle and it's not. So what I'm going to do is remove this, and we're going to create a checker, a type guard that has a type predicate. So we're going to create is motorcycle. And whenever it's returning true, I'm gonna tell it, yeah, if it's returned true, this is gonna be a motorcycle. So now I'm returning trans.wheels equals 2. So now that we have this, we can do something like if is motorcycle, then I can do whatever. And in doing this, I'm making sure that I have a motorcycle. And in the same way, if it's not, guess what? I know that I have a car. So in this situation, this is the moment where you'd have some better control. You could throw something or whatever. And what is actually happening here is that because of this little type guard, what I'm doing is basically the same effect that I would with an assertion, with the advantage that now I'm also doing a runtime check. So I know for a fact that both in TypeScript and in JavaScript land, I'm getting what I need. And so that was it. Now you have one less of a reason to use the assertion and ensure that your type safety is actually spreading out through your runtime. So now you have transparency between what the code you're writing and the code that the browser engine is interpreting. I hope you liked this one. Let me know in the comments, and as always, subscribe, and I'll see you on the next one.